Good morning, everyone. Welcome back to another video. Welcome. So again, I'm going to start with a joke. So why don't Olympic sprinters eat before a race? Because they fast. Okay. I need to share my screen and I'm going to do it via AirPlay because my cable is not really working right now. Technical difficulties, but I think we're still good. All right. So today we are looking at graphing sums and products. And also that includes differences as well of two different functions. Now, I've written just a couple of notes here so I remember what I want to talk about. It's a somewhat tedious process for a very simple concept, and I'll show you what that means because we're going to end up using a table of values. Okay, so it's graphing sums, differences, and products of two functions. And basically everything that we're going to do, we're going to use our table of values to help us to find the sum, difference, or product of the functions. Okay, straightforward. I'm going to keep it short and simple today, or I hope. Let's say, for example, our first function will let fx, will let be fx, and we'll let that equal to x, right? Nice straight line. And gx is x squared. That's a simple parabola. So we're going to use a simple example here, but hopefully we can start to get the idea of how this all works. Okay, so when we're talking about what we'll end up wanting to find is fx plus gx, fx minus gx, or fx times gx. Now, the only thing that we're going to do here is we're actually just going to start to sketch things out. Now, the reason that I picked these is because if we add them together, we should have a rough idea of what they look like. All right, I'm going to draw these underneath. If I was to plus these two functions together, it'll be x plus x squared, or it'll be, yeah, I guess x minus x squared, or it's going to become x times x squared. Okay. Now we know what all of these graphs kind of look like. A being x plus x squared being some sort of parabola that shifted a little bit. Similar thing with B, we're going to get a negative parabola. And for C, we're going to get a cubic. But what I wanted to show you is I wanted to show you the process. So no matter how difficult or disgusting the function gets, we actually have tools to be able to sketch out these sums, differences, and products. Okay. Now, first things first, take a look at this beautiful, beautiful table of values that I've drawn up. We're going to use this and we're going to use it to, normally you would only need one of these extra ones underneath, but I'm going to do it all in one go. It's going to save me a bit of time in drawing all these table of values. So let's begin. First things first, fill out your table of values for your fx. All right, I'm going to use blue. So fx is x. So that means it's just the same thing. So if it's -2, it'll be -2. If it's -1, -1, 0, 1, 2, that's a nice simple one. If fx equals to x, it's the same. Now for gx here, it just means it's whatever the x value is squared. Okay. So in this case, -2 squared would become +4, -1 squared would be 1, 0 squared would be 0, 1 squared would be 1, 2 squared would be 4. Okay, now at this point here, all we're really doing is we are now going to be adding them for our fx plus gx. So what's -2 plus 4? -2 plus 4 is just going to be +2. -1 plus 1 is 0. Is that right? Yeah, I think it is. Yep. Okay, 0 plus 0 is going to be 0. 1 plus 1 is going to equal to 2. And 2 plus 4 is going to equal to 6. Yeah, so that's our one there. Now let's take a look at fx. Take away gx. So now we just go whatever fx is, take away gx. So it would be -2, -4, which is -6. For here, I'm looking at -1, take away 1, -2, 0, take away 0 is 0, 1, take away 1 is 0, and 2, take away 4 is -2. And if we're looking at fx multiplied by gx, again, we're going to always go back to these top two rows here. So in this case, -2 times 4 is going to become -8. -1 times 1 is -1. 0 times 0 is 0. 1 times 1 is 1. 2 times 4 is 8. Okay, so from here, let's use 3 different colors here so we won't get confused. Let's do red, green, and yellow. Okay, and all I'm going to do now is at this point, we're just going to put in our values onto our table or onto our Cartesian plane. So here we've got when x equals to, and I should probably label these out. Let's go this way, -1, -2. Now it's not going to be perfectly to scale. 1, 2, 3, 4, 5, 6, 7, and then 8 will be up there because that's as tall as it goes. Okay, so let's start with our fx plus gx. So when x equals -2, fx plus gx equals to 2. When it equals to -1, it becomes -1. Oops, -1, I should say. So it becomes -1. When it's 0, it's 0. Wait, hold on, I'm getting confused here. Okay, the reason I'm getting confused is because there's too many lines of working here. Let me take a look at this. Okay, we're looking at this row here. Okay, that was a little bit extra, but hopefully we can see that. So our first point is right, -2 and 2. Our next one should be -1 and 0. So that would actually be there. And then I've also got 0 and 0 again. And then I've got 1 is 2. And then I've got 2 being 4. And we can see here that if I was to try my best, it'll kind of look a little bit like this. Okay, now it's not perfect, but it gave us an idea, right? So that means if we had a quadratic, or not a quadratic, if we had a parabola and then we added a straight line graph, it kind of shifts it along a little bit. In this case, it shifted it to the left. Let's see what happens when we minus them from each other. If we have fx take away gx, right? And we'll do this one in green, fx take away gx. So when x equals to -2, and I'm going to highlight again just to help myself out. And okay, green. So -2, when x equals -2, this becomes -6. 1, 2, 3, 4, 5, 6. Oops, I didn't draw it big enough, but that's okay. When x equals to -1, it becomes -2. So it's -1, it'll be -2. Right, because that's -2. That's -6. And then when it is 0, it is 0. And then when it is 1, it is 0. When it is 2, it is -2. Okay, so here we can see that this one here, I'll see, I apologize for these lines, guys, but I hope it gives you enough of an idea to see how these graphs kind of move. Right, so that would be that graph there. And the last one, if we multiply them together, now we are expecting this will be a cubic, but let's just double check and make sure that is correct. When x equals to -2, this would be -8. So it doesn't quite fit here, but that's fine. -1, it now becomes -1. So -1 becomes -1. 0, when x equals 0, fx times gx is 0. When it's 1, it becomes positive 1. When x is 1. Sorry about the language here, guys, but I hope you can see what I'm trying to graph out here. And then when x equals 2, fx times gx equals x to the x8. So 8 would be all the way up here. And if you take a look at my yellow line or my yellow dots here, you can kind of see that it does kind of go through here, and it does give us a kind of cubic looking shape. Okay, so I'm going to put that there. And that there is how we do sums, differences, and products. For all these questions that you do, can I highly recommend, right? Don't try to figure this out in your head, right? These were nice examples where we know what's kind of going on a little bit. But the examples that you're going to do, they're going to be a little bit trickier. And so my suggestion is draw up a table of values, have your X column, have your FX column, have your GX column, right? Or row, sorry, I should say. And then from there, if you're adding them, add the two values of FX plus GX, or if you're taking them away, if you're finding the difference, go FX, take away GX. If you're multiplying, times them together and then graph them out. Okay, that's my suggestion. Always table of values, always find your FX, always find your GX, and then use the table of values to find your sum, difference, or product. Okay, hopefully that makes sense. Hopefully that was a bit short, but I'll leave that there and I'll catch you guys later. Bye-bye.